Alright folks, today we're going to be talking about volume. Before today we only focused on area, specifically surface area, the area of the outside. Today we're talking about volume, which means the inside of our three-dimensional shape. We're going to look at only prisms today, but there's two types. We've got rectangular prisms and then we've got triangular prisms. The difference between those two things, remember, is the base. Okay, so you'll notice that we've got two separate kinds, but only one formula for volume prisms in general. That's because big B stands for the area of the base, and then we can find that differently. Okay, so make yourself a note of that if you don't remember that big B means area of the base, so that we can talk about these different formulas. Notice big B was replaced with length times width because that's how you find the area for a rectangle. Over here, big B was replaced with 1/2 length times width because you find the area of a rectangle 1/2 base times height. You notice they use length and width. That's because it would look a little bit weird if we had two heights in this one formula. Okay, so they use length times width, but that's just the base and the height of the triangle. Okay. Alright, so for me, it's easier to just focus on this area of the base times height because we are used to finding the big B anyway. Okay, so we need big B, but we also need H. Let's go ahead and set up those letters here to the side. Since our base here is a rectangle, we need length times width. So that's 8 times 6, 48. Then our height is that number we haven't used yet, just 7. Putting it all together, V equals area of the base times the height, so 48 times 7. Okay, if you haven't already, grab out your calculator, pause the video for a second, and get that typed in. $336. Now let's chat label, okay, because volume is different than surface area was. When we came up with the base, it was from 8 feet times 6 feet. But then we went ahead and multiplied that by 7 as well. So now for volume, we've really got feet times feet times feet. So that ends up looking like feet cubed to the power of 3, because we're dealing with 3 different dimensions here. Alright, looking at the next one. Volume again, we need area of the base and the height. I like my base to always be on the bottom here with these rectangles, okay, but you can use any side for the base with rectangular prisms. With mine that I've shaded here, length times width would look like 20 times 7. Go ahead and get that typed in. 140. And then the height going up and down on this prism is 9. So volume equals big B times H, 140 times 9. Okay, so 140 times 9, 1260. And then again, volume we decided is always cubed. This case we're working with feet again, so feet cubed. All right. So that's basically the idea with volume. Okay. For the next problem, we're going to talk about cube, but you'll notice that surface area is brought back up again. Okay, so what I want you to do on your yellow sheet, okay, if you haven't grabbed it out, be sure you grab it out, but I want you to find cube on your yellow sheet towards the bottom. Okay. With that, you'll see that surface area is written as 6s squared, but then volume is written as s cubed. Okay, let's talk about why. With our surface area, this s squared represents the area of the base. Okay, with a cube, all the sides have to be the same. So this length would be 4 again, and then the area of that is s squared, or 4 squared. Then with the surface area, we want to add up all the different sides, and there's 6 sides on a cube that are all exactly the same. So that looks like 6 times 4 squared is 16. So 6 times 16 gives you 96. Surface area squared because it's area. With volume, the area of the base is our 16 again, but then the height has to also be 4 centimeters. Since all of these are the same numbers, we can just call that side cubed, or 4 cubed. Okay? What you want to do to type in a cubed, you'll do 4 and this little arrow to the 3rd power. And then you've got 64. Okay, so 64 centimeters, label is cubed. Okay. Over to number 4. Okay, so this is an open box, no top. Okay, so this piece is really missing. We have to find both the surface area and the volume. Okay, so surface area, we need to go back on our yellow sheet and find that formula. It's not on our practice today since it was from the first half of this chapter. Surface area, it gives as the lateral area plus 2 bases. Okay, we want to immediately change that right now because this says there's an open box, no top. Okay, if there's only the bottom and no top, we don't really have 2 bases here, we just have 1. Okay, but now we need to figure out, well, what is LA? Okay, the lateral area is given as P times H. So now, here's what I'm looking at. I've got a P, I've got an H, and I've got a B, so let's set it up. The P and the B kind of go together because they're both talking about the base. Okay, P is perimeter of the base. We've got 5 and 5, 10 and 10, all the way around. Okay, 10, 20, 30. The height, going up and down here, is our 4. And then B is the area of the base, or the area of the bottom. Length times width is our 5 times 10. And that's 50. So, working upwards here, we've got perimeter of the base times the height. Our perimeter was 30. Our height was 4. So we need 30 times 4. Okay, go ahead and type that in. $120. Working up again, it's lateral area plus 1 base. Our lateral area, we said, was 120, plus 1 base. Our base was 50. So we just have to take 120 plus 50 here, for a total of 170. All of this is area, so centimeters in this case squared. All right. The good news is we worked hard for surface area. We've already found most of the things we need for volume. Okay, volume is, remember, area of the base times height. We found the area of the base. That was 50. We found the height in our prism to be 4. So we just have to take 50 times 4. 200, and then centimeters cubed. Okay. Now we're going to work on triangular prisms. Okay, so the first thing you're supposed to do with a triangular prism is always shade the base. Remember, the base for these prisms are those triangles. Okay, so you get to focus on whichever triangle you see first. Okay, I like to try to find the one with the most numbers labeled on it, but either one's going to work for us because they're the same size. Okay, so I'm going to focus on this one, and we're dealing with right triangles, so go ahead and put that box in there. Now, you'll notice this triangle has 2 things labeled on it, this 4 and this 3 going across, but this slanted side is 5. We can also put it on that triangle as well because they are the same size. Right, now our volume is all we're looking for here. Volume is exactly the same here. It's base times height. Okay, but what's different here, that capital B is the area of the base, and for us, the shape has changed, so the formula changed. Since we got a triangle here, we're doing base times height over 2. Okay, so base times height over 2. This is on the top of your sheet, the 1/2 length times width. Okay, they use length times width instead of using that B repeated. Okay, but we're just going to go ahead and take the height and the base, the two numbers that meet at the right angle, and divide it by 2. So 4 times 3 is 12, divided by 2, 6. Height, remember, you got to be careful here. Height is not going up and down on this one. We've already used that 4. Okay? It's the number we haven't used yet. We've used the 4, we've used the 3. Now this 5, okay, before when we're doing surface area, okay, we had used that to find the perimeter. The height, you'll notice here, it says it's the distance between the two triangles. Okay, so on this picture, it's going kind of left and right here. So our height is the 2. So then, base was 6, height was 2, volume 12 feet cubed. Right? Over here, again, shade your base first. I want you to pause the video, set up the letters that you need for this formula, see if you can find them. Volume is area of the base times the height. Area of the base in this case is base times height over 2. Base and height meet at a right angle there, 6 times 8 over 2 is 24. Height here, again going left and right, is 7. Now you may have noticed that this slanted side here is missing, but since we're only asked to find the volume, and that's not the height of the triangle, and it's not needed for the area of the triangle, we don't actually need that distance to answer this question. Okay? So, volume, putting it all together, 24 from the area of the base, times 7 for the height of the prism here. We're taking 24 times 7 to get 168, and again, volume's always cubed, so feet cubed. Alright. Next couple, we're going to bring back surface area. Okay, so now I need you to locate prism on your cheat sheet to find the formula for the surface area of a prism. Okay, again, it's lateral area plus 2 bases. Lateral area is still the perimeter times the height here. So we need P, B, and H. Okay, I grouped the P and the B together like we're used to seeing because they both talk about that base. Okay, remember your bases are the triangles here. So we've got our right angle box there. Perimeter of that, we do need this missing side for because the perimeter is adding all the sides of our triangle. We've got 3 sides. Okay, so pause the video. I want you to set up Pythagorean theorem to solve for that missing side. Alright, x is 13 here. Put it on your picture because that's not our perimeter, that's just the missing side. So now we're taking 13 plus 12 plus 5. 30. Area of the base, look at the shape. It's a triangle, so base times height over 2. 12 times 5 over 2. 30. And the height, in this case, really is the number we haven't used yet, okay, but it's the one going between the two triangles, or between the bases, 6. All right. Now we can go ahead and put it all together for the surface area. Okay, so lateral area is perimeter times height. That's 30 times 6. And then surface area is the lateral area, 180, plus 2 times the base, 2 times 30. 240 all together. Inches squared. Now remember, we had to work hard to get all of these pieces for the first part, but then volume should be pretty easy. Okay, so volume is equal to area of the base times the height. Area of the base was 30. Height was 6. So 30 times 6, 180 inches cubed for the volume. I want you to pause the video, take a chance to work on number 8, surface area and volume. Okay, then you can check with the video when you're done. Okay, so you had to find this missing side in order to find the perimeter of that triangle, our base. Okay, so that was 17, gives you 40. Then the area of that base, 15 times 8 over 2 is 60. The height between them being 10. So surface area is the lateral area. That was our P times our H, 400, plus 2 times the base, which in this case was 60, to give you 520 centimeters squared. Notice this bottom says inches. That's just a typo. We're all in centimeters there. Right. Then on the next one, volume, area of the base times the height, 60 again times the height 10, you get 600, and then centimeters cubed. Okay? So that's volume of our different kinds of prisms, both rectangular prisms and triangular prisms. Okay, go ahead and flip it over, and we've just got a word problem, because the hardest part is then deciding when are we supposed to use these formulas surface area, when are we supposed to use these formulas for volume when we're dealing with a real life situation. Okay, so we've got a gift box with dimensions 24 inches by 20 by 3. Okay, so first thing we're going to do is sketch this, a box. We're going to start with a rectangle. Alright, then we'll go ahead and draw another rectangle the same size. Using your geometer on this will make it look neater and also help you make sure that your rectangles are the same size. Okay, from there you just connect your corners and you've got a box. Alright, now what I like to do is use my smallest number as my height going up and down. Okay, it doesn't really matter where you put it, and then your other two will be on the bottom. Okay, so height, one of your numbers goes up and down, and then your other two are going to go on the sides of the bottom. So 24 inches here, 20 inches here. Now, the first question asks us, can the box be completely covered by a 10-foot square roll of wrapping paper? Okay, so this word covered tells me outside. And outside tells me the surface or surface area. Alright, so we need to find the surface area. Since this is a box, our formula from the cheat sheet, okay, lateral area plus 2 bases. Lateral area is perimeter of the base times the height. Okay, so we need all these things, P, H, and B. So P, B, H, like we're used to. Alright, now we got to go fill in some stuff. Okay, so our base here, the bottom, we need the perimeter of that. Okay, so we're taking our 20 plus 24 plus 20 plus 24, all of our four sides on the bottom there, to give 88. The area of that base, length times width, so 20 times 24. $480, and then the height is 3. Okay, go ahead and put that all together to find the surface area. Okay, so pause the video and take care of that for me. We got 88 times 3 plus 2 times the base is 480, with a total then of 1,224. So I'm going to put that over here. We need to think about what label we're in right now. Okay, so we are working with inches and inches and inches. Surface area is inches squared. The reason I'm asking you to focus on this is because our question talks about feet squared. Alright, so now we have one more job. 10 feet squared, I want to know, is how many inches squared. Okay, well, let's talk about 1 foot squared. We've done this before earlier in the chapter, okay, but this is 1 foot squared, so 1 foot by 1 foot. We really know that's 12 inches by 12 inches. The area of this, 12 times 12, 144 inches squared. Okay, so we can say that 1 foot squared is 144 inches squared. We've got 10 of them. So we'll take, just to get our answer here, 10 times 144. That'll give us our amount of wrapping paper in our inches squared, so we can compare them. Okay, so we have 10 feet squared to work with, which makes 1,440 inches squared, and our shape only takes up this much. So when we're asked, will it work, will it cover our shape, we can say yes, because this number is smaller than the number that 10 foot squared looks like in inches. Okay. Now the next part B says, how many cubic inches can the gift box hold? The word hold usually indicates inside, but in this case we saw cubic inches. That also tells us volume. Okay? Since it says cubic inches, our life is nice because we don't have to work about any conversions here. We've got B from above was our 480. Our H from above was 3. So our volume is just 480 times 3, which is 1,440 cubic inches, or inches cubed. And that's it.